Alright, hello everybody. Happy Halloween. Today is EDAD, Research and Data Assessment in Education Spooky Correlations, Part 1. Our roadmap for this week, we are going to discuss correlational methods and analyses. Basically, a correlational method is a method that's designed to measure two variables or more variables that relate to one another. So we're going to spend a lot of time talking about basic correlations, and then we'll talk a little bit of time about talking about more advanced correlational analyses. And then finally, we're going to do a class assignment that you'll create to get credit for quote-unquote attending this course. And throughout, we'll do a little bit of Halloween fun. Okay, here's our research process hourglass. We're in research methods. We're doing a correlational analysis with the data here that we receive. So the method is correlation, and the analysis is also correlation here. So correlational research measures two variables to see their relationship. And what you see here is what we call a scatter plot of different correlational analyses. The first one is a perfect correlation, the one in the middle is a no relationship, and the one on the right is a perfect negative correlation. So let's take a look at some of these. Correlational research are data collected on two or more quantifiable variables to determine whether a relationship exists and to what degree that relationship is. Now, a degree of relationship can be expressed, as I mentioned before, on a continuum from +1, which is a perfect correlation, one-to-one relationship essentially, to 0, no relationship, and a -1, which is a perfect negative relationship. And we'll give some examples of that here in a moment. What you see here is the relationship between IQ and grade point average. So we've got IQ on the left, grade point average on the right. We're going to plot those data, which is a typical first step with a correlation, with GPA on the x-axis and IQ on the y-axis. And so as you can see here, as participants with higher GPAs are associated with higher IQ scores. Right? We've got a 1.0 having a relationship about 85. Score of 2 has a relationship of about 100 GPA. A 3 has about a 120 or 130 GPA, and so forth. So this is a great example of a nearly perfect positive correlation. 0.966 in fact. And again, these are fake data, just used to show the example of how these things come together. The examples that we're looking at here come directly from your book, and you can find them in the chapter on correlational methods. Let's take a look at another example of IQ related to weight. Is there a relationship between a person's IQ and their weight? I wouldn't think so, but let's take a look. We plotted here weight going across the x-axis. We've plotted again our IQ on the y-axis. Here's our individual plots. Is there a relationship? Is it positive? Is it negative? So it turns out when we calculate this correlation, there is no relationship. This is almost 0. Our last example here, we've got IQ and the number of errors on some sort of assessment. Again, we're plotting errors across the x-axis, IQ across the y-axis, and we see with increased IQ, we see fewer errors. So what kind of correlation or what kind of relationship is this? Positive, negative, or no relation? You guessed it, negative. And again, this is pretty close to a perfect correlation, 0.89 with negative 1 being a perfect correlation. Here is another guide to interpreting correlation coefficients. We often see correlation coefficients around 0.35 or negative 0.35, and we believe those to be low relationships or no relationships. Rarely do we see a perfect 1, a perfect negative 1, or a perfect 0 relationship. So we like to look at different benchmarks, and this is the benchmark for low or no relationship, something that's below 0.35. When we see a correlation coefficient between 0.35 and 0.65, we believe that that's about a moderate relationship. And then if we have a relationship that's greater than, a coefficient greater than 0.65, we see that as a high relationship. Again, we interpret these degrees of relationship for high or low as at absolute values. So 0.65 or negative 0.65, either direction, it's a high. So 0.65 to negative, excuse me, 0.65 to 1 or negative 0.65 to negative 1, those would be high relationships. Another benchmark here, we're comparing the Wechsler Intelligence Scale for Children with the Stanford-Binet tests. And looking up here at the top, a 0.77 coefficient is the relationship between the Wechsler Intelligence Scale and the Stanford-Binet Composite Scale, which is all of the scales combined on the Stanford-Binet. And these are both measuring intelligence tests, and we see that these tests are highly related at a 0.77. Now, on the other hand, the Wechsler Performance Index compared to the Stanford-Binet Verbal is not related. It's near to 0. And if we compare the Wechsler Performance with the Stanford-Binet Visual Reasoning, we see a relationship, but kind of a moderate-sized relationship here. Now we're going to pause here and take up on part 2.